Tonight, our speaker comes from the University of Washington. I spent a little time at the dinner debating with him whether it would be more meaningful for him to just walk away and renounce his doctorate without getting it, or whether he should. But that's neither here nor there, because tonight we're going to see what the goods are that he would get his dissertation on. He was a Berkeley undergrad, took a class with James Landay, had James Landay write his recommendation for graduate school, and then ended up going to UW, where James Landay was his advisor. Michael Toomim, please.
Thanks, Paul. Wait, are we done with these slides? Yeah. Okay, I'll just cover them up. Cool. Okay, so this is cool. I'm really excited to be here. Yeah, I used to be here when I was an undergrad, and that was, I think I went to a BayCHI meeting in 2000, and this is my first time back, and it's kind of cool, you know, because I was a kid. So, okay, so I've done this work with Travis Crippling and James Landay, my advisor, and then you also see Klaus Portner, an economist, which is a little bit odd for HCI work. And this is what I'm trying to do, bring some of economics into HCI. And this is a talk about how I think that can fit into the heart of what we do. So here's a question to look at that. How much do users like your interface? And this, when we design interfaces, this is what we want. This is the end goal, right? If you look at it in a slightly different way, you know, wouldn't you really want if users could love your interface? And aren't you trying to optimize for it? Find the interface that provides the maximum amount of value to them. But the question is, can we measure this? Can we look at this scientifically? Can we optimize our core value as HCI people, like scientifically make a science of this? How would you measure this? How would you measure the aesthetics of your interface and how people like that, or how fun it is? Nobody's answering, I guess that's cool. I'll just move on. So you can kind of think of this as, one reason it's hard to measure this is it's a net value. This encapsulates a lot of things. We know how to measure things like if an interface is efficient and accurate. We can give people tasks in the lab and see how long they do it and see how many errors they have. We also want to measure, it also matters if an interface is like user-friendly and learnable. It's a little bit harder to measure that. And it gets even harder to measure things like if it's fun or pretty, intuitive, or sociable, which seems to be really important. You can't really measure this stuff, but you really want that thing on the top. You want to know how all this trades off, how all these values weigh against each other, and what's important at the end. So now I'm going to show you a way to do this. And the basic idea is we can take a task in an interface, and we can put it in an online labor market. So we pay people to do the task with the interface. And then we see how much you have to pay them to do it. And if you have to pay them more, it means your task sucks. Watch this magic without pushing the buttons. Okay, so this is an interface for filling out CAPTCHAs. This is really exciting stuff. No, it's not really. This is just a standard CAPTCHA interface. What I wanted to do is find out, could I measure the value of aesthetics? So I took this interface, and I made it really ugly. I gave it this flashing, horrible banner advertisement, and it's like green and gross, and you can't even click on that ad if you get interested in it. It doesn't work, just to spite you. And so I found out that, basically, so I posted this at a bunch of different prices, and then I could measure that the value of this ugliness was negative 0.6 cents over 10 CAPTCHAs. We could actually measure it. Okay, here's another example. This is a Fitts law study. So you click on this blue thing and then it moves to the side of the screen, then you go and you click on it again, it goes back and forth. And we run these studies in HCI all the time because there's this magical law that tells you how long it takes to click on them. We've run like hundreds and hundreds of these studies. You can make the bar smaller, and then it takes longer to click on, and that's what we figured out. And you can make it really, really small, and it's really hard to click on. We've done tons of these studies. We've never measured how much it matters. How much do people care if a button is big or small, easy or hard to click on? So I ran a study, the same thing. I paid people a bunch of different prices, and if you're going from that medium bar to the tiny one, it's negative 3.8 cents. That's how much it's worth to people over 60 clicks. And if you go to the big bar, then cent and 1.2 cents. And so now you can take these numbers and you can compare it to the value of aesthetics, and you can see, oh, okay, well maybe if I make this really ugly, then it's worth about this much in bar size. So, okay, cool. So that's my example. So now we can take all these little things that we care about, we get an aggregate measure. And I'm introducing this measure and I'm calling it utility. No, I didn't call it utility. This is an economic term. So in economics, utility is defined by choice. The choices that people take defines their utility. If I choose this thing over this thing, it means that this thing has a higher utility. And this measure captures everything that goes into a person's decisions. You don't have to know what's going on in their head. You just see what choices they're making. And we can put this into a common language of dollars and cents. And that lets us compare the utility across different interfaces, across different aspects of interfaces. So, okay, so I think this is what we really want to be looking at as HCI. And the rest of this talk is going to talk about HCI through the lens of utility. Here's a little outline. So we've got, I wonder if I can get my mouse, cool. So we've got utility as an aggregate measure for evaluating interfaces. Then we'll talk about the history of HCI and how utility sort of weaves its way through there. We'll talk about how to measure it now with actual economics and labor supply curves, and how I see this going into the future. So, okay, utility measures the human will to choose. So it's kind of core to people. It's your will to do something, and really it's about choice. So this word choice, this is a big word in HCI history. This is the textbook history from Jonathan Gruden. For those of you who've seen a talk or something about Jonathan, he has great histories on HCI. And his histories talks about HCI as this trend of discretionary choice, as people could choose their interfaces. This created our field in a lot of ways. So let me take you through it really quickly. In the 1960s, this is what computing looked like. You had a bunch of paid operators, and they were going to be like, in the nuclear submarine, or calculating ballistic missiles, or operators of a telephone switchboard, because the computers were these mammoth things. So the people there, they don't really have any choice in what to do. They're paid to do this as part of the job. They'll actually have paid training. They'll be paid for a week to learn how to use an interface, learn how to use a system. So the system doesn't have to be easy to use. They're just paid to do it. And all that really mattered when we're designing these was speed and the errors. And the field of human factors captured this. They were like, let's make this interface fast and error-proof. Okay, so that's the 60s. In the 80s, all of a sudden, well, you could put a computer on a desktop. And, whoa, there's a lot of them. You can choose amongst them. If you don't like this computer, you can buy a different one. If your secretary didn't like a word processor, she could use a typewriter, or she could switch back and forth. There was a commodity software market. Now it's even easier to choose. You can just swap disks. You don't have to change the physical thing on your hardware. You can be sitting on your couch and use something else. And companies had to market these things. Apparently we like that. So, okay. So suddenly, because we had this choice, the design suddenly needed to be user-friendly and learnable. And this is where the field of HCI came from. So when users have choice, so this is the relationship between these two things. Choice, and then HCI has to design for what users want, because they can choose. Okay, the environment determines what we have to design for within that environment. And you could also see this as we're designing for what they value. When users have choice, we must design for utility. We didn't really have to before. Okay. So, human factors was big in the 60s. Chi came out of the 80s. The field of HCI was born of choice. So now let's look at the values of the field when we were birthed into the world. And just look and see what that was a little bit. So let's go back to 1983. Let's go to the first Chi conference ever. And in the first paper session of that conference, and the first paper presented in that session by one of our luminaries who happens to be sitting in the 5th row. Everyone look around. Where is he? he's not even looking. He's so modest. That's cute. So this was his paper, Design Principles for Human-Computer Interfaces. And in it, he's talking about when we design an interface, we should find this user satisfaction function, U of X. And we can make trade-offs by looking at this scientific function and being like, is this function better for interface A or interface B? And then we can scientifically know what's a good interface. And that was pretty awesome. So here's an example, like we have these great graphs. When menu size gets bigger, the utility of the menu size goes up. When the display time gets bigger, the utility goes down. Yeah, because you want display time, you want it the other way. But Don Norman couldn't actually measure these things scientifically. He just kind of drew these and was like, this looks pretty good and it makes sense to do. And maybe in the future we could measure them. And I actually found this paper after I had done the research to make this graph. And I just thought it was really interesting. So I have here the index of difficulty for that fits law task. And the utility of the index of difficulty is on the left. And it looks a lot like the graph on the right for display time. And I was like, wow, that's really interesting, actually. So I was thinking, man, it looks like this is a precursor to utility. Even the function name starts with U. It's kind of cool. And then actually I was like, and then it's also UX, which is like user experience. So I don't know, maybe we're all just like linguistically intertwined. But at the high level, HCI, our field, is a response to choice. When users could choose a tool, we needed to care about user satisfaction. Okay, but that was the 80s. Now we're in the 2000s. We have the internet. We're not even just choosing tools now, we're choosing tasks. When you use Wikipedia, you don't have to use Wikipedia. You could be posting a status on Facebook. You don't have to do that. You could be on Twitter. You don't have to do that. You could watch TV. You don't have to do any of that stuff. You can be on Mechanical Turk earning a living. And, like video gamers pay money, a lot of money, to have other people go and define arbitrary tasks for them to do that are and make them really fun for them. These are just arbitrary things. We're in this business now of just creating tasks for people. And choice is ever more important. How do we study this? We went from human factors to chi, and what's over here? Let's find out, I don't know. Oh, industry's response, A/B testing. Okay, cool. Yeah, actually this kind of works. So industry's like, yeah, choice really matters, let's measure it. So they have A/B tests. They actually change their interface with real people and they see what they choose. That works really well for them. It doesn't help us as a science. It doesn't help us build a knowledge base in our field. Through all these A/B tests that have been run by Google and Amazon, we've learned some interesting things, like on Zynga, a pink button really helped one call to arms for a particular sale that they were trying to do. But we can't generalize that result to other websites. We haven't learned general knowledge from these A/B tests. And they're very inaccessible to run, not just to scientists like me. I can't build a huge website to test out a theory, but they're inaccessible even to people within the company. So I was talking to some people at Bing, and they're like, yeah, we have these great A/B tests. At very few times can we actually run production code and find out a difference. The results don't generalize, and it doesn't say how much something matters. If you find out that you get 30% improvement in click-through rates, you don't know if that matters to people. Maybe they're watching TV and they had nothing better to do, right? Or maybe that's 33% that actually means something, but you can't distinguish between them. So let me show you how we do it. Okay, utility, the concept from economics, we measure it using choice experiments. And I'm going to demonstrate one method that uses Mechanical Turk. There's many other methods to do this. You don't have to use Mechanical Turk. Cool. Okay, Mechanical Turk method. I post variations of interfaces and tasks to Mechanical Turk at different prices and record the number of tasks completed per condition. This is that boring part of the talk where he's reading the slides. Okay, awesome. I love this guy. So we're kind of using Mechanical Turk backwards from everybody else. We don't care what people actually do, the work that gets done. And we just measure the money that we pay them to do it. I just thought that was funny. Okay, so this tells you a little bit, it shows you how the tasks get posted. We don't want to bias the users in it. They get slotted randomly into a condition of a user interface and a price. They don't see anything about it until they accept the job. And as soon as they accept it, we're tracking them. So we know everything about what they've seen and how much work they've done. So here's the Fitts Law study again. Okay? So we have these 3 different conditions of bar width. I had 6 different conditions of price. Every user would get 1 random condition of bar width and price, so that's 18 conditions. And now out of that, I get 3 different amounts of work. So on the y-axis here, this is the amount of jobs that the average worker did before he quit. So on Mechanical Turk, you're doing a job, and then after you finish it, the default is that you'll get another one of those jobs. And you can keep doing that until you stop. Or you can go do something else and come back and do it. In any case, this is the amount of work that you did. And on the bottom, you can see the interfaces. So skinny bar, medium bar, big bar. Big bar, people do more work. They like it. It's better. It's more fun. I had a girl I was dating once, she was like, this is really fun. Can you give me more of these tasks? And I was like, are you crazy? But she hated the small bar. Okay, but here's the trick. We're also paying people different prices. So that was an A/B test. Now we spread each bar across into a line. And you can see as we pay more money on the x-axis, people do more work on the y-axis. Okay? This is a standard economic display called a labor supply curve, which is pretty cool. You can do stuff with it. So I'll show you something you can do with it. So let's say, okay, we have these 2 interfaces, A and B. What if we want to compare them? So let's say we'll fix the amount of work done and say for the same amount of work, what's the difference in pay that takes us between A and B? And if we draw that down onto the pay axis, we see it's 3.8 cents. So we just found out now the value of changing that interface. It's amount of money that gets you the same amount of work. Okay? So this is it. That's it. I'm done. But there's more. So, so now that gives us the way to value an interface. Just for some general high-level stuff, this study takes about 5 hours. Costs $200 to $2,000, depending on if you only want to pay people 1 or 2 cents, or if you really want to see what happens when you pay them 10 cents. That's 10 times more expensive, and is it better data? It depends on what you want. Cool thing about this is that another scientist can rerun your code just by hitting a button and paying a lot of money. So you could go give this code to someone else, and they can be like, I want to try tweaking your experiment like this, and try a different method, or a different something, or whatever. And then you can compare the results. You're using the same population of people, no matter where we are in the world, the same lab. It's very controlled. You can run surveys on there to get demographic data and see who your people are. It's pretty convenient for all these reasons. So this is really good for establishing benchmarks. I'll talk about that more later. I've got this software system. I'm calling it the utiloscope. You give it a UI and some money, and it runs a study and gives you the utility. So you feed it in, and it comes back out. And it gives you some graphs, does some analysis for you. It doesn't take that much work. You just kind of have to implement your interface inside of a little iframe that's going to go on there. And then there is a tricky part, which is verifying that the Turkers did the work that you want done. You always have to do it on Mechanical Turk. And it's actually really important here, and it's kind of the tricky part in doing these studies, because the enforcement function, like if you want people to write a paragraph of text, it really matters on what is a good paragraph of text, what you want them to write it on. Are you asking them to write an email? Is it a particular kind of email? So this comes up to the study design. You have to come up with a good way of doing it. There's a bunch of techniques. The cool part is that I want to collaborate with you so that I can implement all these techniques and have a place to test it all out. So I'm very interested in collaborators. If anyone has even not just an interface you want to try out, so if you're a startup, maybe you want to try some new interface and see if people like it. If you're at a big company and you want to try out an interface, see if people like it. If you're running experiments yourself, I'd love to test these things. I'm doing benchmarks for CAPTCHAs, so people are designing different kinds of CAPTCHAs. If we have a benchmark of it, then different companies can compare their CAPTCHAs, because the goal of a CAPTCHA is to be not annoying to the people who are legitimately filling them out. Although then there's a twist on it. You probably want it to be annoying for people who are paid to fill out lots of CAPTCHAs in India. Or maybe it's not, oh no, it's Vietnam right now. And modeling, and I have working with some modeling user annoyances security. And I'm also, well, I think, yeah, cool, this is coming up. So, cool, that's how you do stuff on Mechanical Turk. there are some limitations to using Mechanical Turk. So you might have noticed that we can't really, I haven't told you how you're going to get specific user groups. You're like, but these are Turkers, they're not representative. And another thing about this is that I'm only measuring the kind of the negative part of using an interface. Like, it's just annoying to click on this a bunch of times, and the Turkers don't want to do it for any reason. You couldn't, from that experiment, get measure the value of uploading photos for your daughter, because I would be paying some random person to upload photos of your daughter. And they don't really care. So I want to show you now, if you were to take all these techniques and put them on a real website instead, which is, I'm really interested in finding collaborators for this because I don't have a real website right now. Then we can measure the value of situations, and we get real users in real situations. So here's an example of how you might imagine doing this. Maybe if you're Google, you put a little ad, beta test for Google, up on the side, and that recruits people who are using Gmail to try out some experimental new interface. And maybe when they're doing that, you put little price tags next to certain tasks. So instead of just doing this for free, you're like, oh, well, maybe I can get a little money doing this. And you can see now you have a beta pool of people that you're recruiting, and you can learn how much they like new interfaces, and you can get them to try out new things. So this fits into this greater space of utility measurement that's not just Mechanical Turk. And I'm not going to go into this in super detail, but I'll show you. Traditional A/B tests are in the upper right. What I showed you is right here using a labor market. And I've just shown you some examples of stuff in the bottom right. And this is a key part. So this is something else I'd like you to take away from this talk. If you're interested in utility measurement, whenever you're running these studies, the overall utility is going to be equal to the value of the goal. So like, I want to upload these photos for my daughter because it means something to me. But in order to do that, I have to go through this process of using a computer, and that part sucks. So the value is mostly good, the cost is mostly bad. And if I subtract these two, I have the overall utility. When we run these studies on the labor market, we artificially substitute for the value some amount of money. If we put this on a real website, we're going to be able to measure the whole thing. And so if we can combine these two methods, then we can distinguish. We can find out what's the cost of the interface and what's the value of the goal. And let me show you a little bit more how that works. So this is a way to get the value from an experiment with a real website. So if you have a regular website and it's a regular A/B test, you have a bar with the amount of work that people are doing. Okay. This is just the amount of work that they're already doing. Now let's pay them some money. So if we're going to pay them a cent, we pay them 2 cents or 5 cents. What's going to happen? It's going to make them do more work, depending on how much we pay. So our bar turns into a line, the labor supply curve, and it starts in the same place, but as we get 1 cent, 2 cents, it goes up. Okay, now what's happening over here past 0? If we project this line down, at some point it's going to cross the axis. What does that mean? Well, if we look at the distance from 0, this distance from 0, this is the amount of pay that it's worth them in order to do 0, or in order to do that amount. Man, I can't even explain this that well. Can anyone else explain this? That'd be cool. Yeah, I think it's actually the net value. So because yeah, that would be, if you paid them negative amount of money, then that's the amount of money you'd have to pay them for them not to do anything, to not use your website anymore. But yeah. Yeah, you have to pay them not to do it. Yeah. What's up, Don?
Have a task that's intrinsically enjoyable.
Yes.
So if you look at vertical axis at 0,
Yes.
that tells you how valuable this task is. They were willing to do it for no money. And then as you go to the left, That tells you how valuable it is, because it tells you how much they're going to pay you. Negative money means they pay you.
Yes.
How much they'll pay you in order to do the task, right?
Yes, yeah, that's exactly it. That's exactly right. Okay. So, good. I'm glad that you understood this better than me. Should I use this? Oh, okay. So, yeah, so this is the amount of money. This is basically the excess capacity that you have here. And it's almost the value, but it's the utility because it includes the cost as well. So what you're saying is right. So what does this mean for us if we have this amount of excess capacity in our user interface? What can you do with this? Well, you can use it for advertising revenue. This tells you how many ads you can put on your site if you measure the cost of each ad until you drive all your users away and become MySpace. This tells you, how much if you work it, how much more work you can get people to do, to upload status updates. Love those things. Or photos posted, how many Wikipedia articles can you get edited? Or how much crowdsourced game work can you get done? So maybe you take an interface in a system and you make it more fun. If you can measure how much more fun you made it, now you can talk to your boss and you can be like, hey, look, here's how much we increased our bottom line by making this much more fun. Let's check my notes, make sure I'm saying everything. Yeah, awesome. So you can trade off these things. Okay. And this is where I'm starting to switch gears a little bit. So this is the capacity for human attention. Human attention. So this is what utility is doing. It's getting human attention. And this gap is the amount of extra human attention that we're getting. Attention economics. So Herb Simon talked about this in 1971. He said in the information age, the scarce resource is human attention. Because we have so much information out there, information is no longer scarce. What's scarce is what information is consuming, which is us, which is our attention. And it's not even just information. This is also tasks now. We have so many things to do that our attention is really scarce. And this is the way I see it. Through the lens of utility, this is what runs the web. This is what fuels Facebook and Google. Their money comes from ads. And ads are human attention. The more human attention they can attract to ads, the more money they make. This is what Wikipedia runs on. Human attention. Human attention to make articles. And people make articles because there's human attention to people reading articles. It's a big pipeline industry of attention. So what is the relationship with utility? To get at that, I want to take you through this picture. How many of you know this picture? Okay, not that many. So,
7, right? About 7.
About 7? Oh, thank you. That's great. I love these numbers. And 70 people, this is cool. I like stats. So, and what's your utility on this? Okay. So, okay, this is a model human processor that Stu Card and someone else made. Awesome. That's so fun. Right here. Oh my God. That's cool. They don't do this in Seattle. It just doesn't happen. So this is pretty awesome. This is the human as a computer for the purpose of interface design. You want to know that they have a perceptual processor. It has a 100 millisecond delay. There's a visual image store. It has some delay, auditory image store, and all this stuff feeds through. And this is how people process stuff. This is really great. Okay, from the lens of utility, what's missing from this picture? If we're going to have a model of people, and we're going to use this model, so we use this model in order to predict things about interfaces and choose what to build. What's missing from this from the utility lens? Effort, that's a good guess, yeah? Well, that's not what I'm thinking about, but it's very close. Preference, oh, preference, that's really good too. That might be what I'm thinking about in different words. User intent, whoa, that's really good from search engine vocabulary. Desire, yeah, I even forgot what I'm writing now. These are really good.
What is really missing in what you're thinking now is called the human demographic spectrum. The human demographic spectrum is a very important point. I know you will cover it, or you may have thought it. But that's the most important one. There's not what's called a single monolithic human being anyway, right?
Yeah.
And it changes with time, changes with age, changes with location, changes with purpose,
Yeah.
and a lot of those things, that's still missing. Yeah,
That's-
in a lot of these things. Yeah. Because I told you that I'm doing video game-based education, where I want to make sure the kid plays. Here in this kid, there's no money involved.
Yeah. Yeah.
You know, all this value is a different concept altogether. To make the kid play, and parents, play, and what's called payers were the parents. And that's the payer versus player, which is totally different people altogether. It's
Yeah.
a lot more complicated.
Yeah, I think you're totally right. In fact, I think that is a much bigger missing thing from this picture than what I had prepared. And the best I can answer that is say yes. That's the complex part that I'm not really able to talk about much yet, right? So far, it's like we can do some demographics, but we'd like to get there more. Meanwhile, I can just continue on with my pre-programmed agenda, which I even forgot now that you gave me great suggestions. I was thinking we need a model human chooser. Okay, we need to understand how people choose, which is pretty much what you guys were all saying. You can also think of it as an attender. What's deciding the attention? Here's my image. I made it in 5 minutes. So you got a bunch of neurons on a person, and the person, there's something in here that's choosing what those neurons are going to be occupied with. You have a bunch of choices on the right. They have different amounts of money. And what money does is it focuses your attention. It's this added little thing that is going to drive your attention towards one thing or another. It doesn't make you work harder or faster because that doesn't exist. You're just a processor. You have the same clock speed as anyone else, unless you get burned out. It focuses your attention. And we need to have a better model of this. I just started learning about some behavioral economists. I can't even pronounce it that well. And Paul was telling me about some great things in that field. I need to learn more. Here's one thing I found. Daniel Kahneman came up with this 4-level utility model. First, you experience something, but that experience doesn't determine what you're going to do next. So here's this is 2 patients' experiences during a colonoscopy, which has, they call this y-axis pain intensity. And this one was much longer, okay? And you might ask, are the patients going to go back to do this later? What's their chance of doing that? Well, it's going to depend on how they remembered this experience. And then they're going to predict it and be like, okay, was that great or not? I don't know. And then they're going to make a decision. So how do people remember this? And he's like, the way that people remember experiences, they focus on the peak and the end value. So with this first experience, it was shorter, but it ended on a high point or a low point. It ended on a painful point. This bottom one ended on a lower point. And he did some experiments, and he showed that people would actually choose longer, painful things if they decline slowly in the end, because they're remembering the thing at the end a lot. So this kind of screws with us a little bit if we're trying to create a nice little model, but at least let's keep going at this. I think it's important. But this is what the model human attender might look like. It might have some pieces like this. I'd love to find out more about that. And I think this is now in the talk where I start getting to why. If we understand an individual's utility, then we can know the capacity of social systems. So if we can do these utility analyses, which is kind of looking at model people, what happens when we put people together into organizations, systems of people? Here's a little diagram I made in Emacs to illustrate this for you. So this is HCI. We have humans, we have computers, and there's a little X where they interact, right? We're studying this, interaction, human-computer interaction, HCI. This is BayCHI, which is backwards. And then, so this is cool. I really like this field. I'm in it. I've been in it for a long time. But what's really exciting these days seems to be more like, hey, we can have lots of computers and lots of people, and this stuff seems really interesting. So now we have, oh, there it is. Okay, cool. Now we have human-computer systems, lots of humans and lots of computers. And now I want to make something clear here. This is a system. This is something that we can design. This is something we can analyze the properties of. So let's contrast this maybe with like the closest subfield within this area of HCI called CSCW, which is computer-supported cooperative work. In the name, they're looking at supporting work, computer-supported work. And they're actually trying to rename it, but they're still stuck with that name. So this is kind of an HCI perspective. Let's go out in the world and let's look at some work. Let's do ethnographies. Let's do contextual inquiries. Let's see what's happening here. And then let's support these human goals. And we will just be like nice people supporting these things. I'm going to suggest that we actually try to design them. So, because I think the exciting work these days is in defining completely new types of tasks and completely new configurations of people, things that don't exist out there, in new systems of humans and computers. And, okay. So here's the challenge in this. In computer science, there's a lot of things we'd like to be able to build, and there's some things we figured that we can't build. There's limits, because the computer has certain resource limits of time and space. And the algorithms we design are built around these resources. We try to make things efficient and fast and not use too much RAM. What is the resource, though, of humans? For building a system of humans and computers. Now we have time and space for the computers, and for the humans, the resource is attention. This is why all the websites we're building they're fueled by attention, and they all want to attract as much attention as possible. And if we can understand utility, then we can start to understand how to build systems of attention. So, this is the end of my speculative part. I just think ACI can be the science of human-computer systems. If we take on this bigger task, if we look at attention, look at what's possible to build. Maybe we could build just new organizations of people online. You know, Paul was talking about being pessimistic about certain things. Old internet dreams. You know, it was like, I think we were talking about could we build an economy where musicians can still make a living, even though their MP3s are stolen and borrowed and shipped everywhere? Can we build these things? Can we build a better government? These are all just organizations of people where we can build new things with the internet. The limit is human attention. The limit is how we can organize people to think together. And HCI can be the center of that. HCI can be designing these human-computer systems if we build a science of attention. And then I have an animation. This is my research group. It's called Dub. And we're off to the future. And once again, I would love to collaborate. And that's it. Only 36 minutes, man. Okay.
Thanks, Michael. I had a couple of questions. One would be, you said that there's a limited supply of these Turkers. So at the point that you start to cycle through them, you said that typically there's about 1,000 available when you're running an experiment.
Yeah.
And you know, one of the issues with actually calibrating some of these utility functions is the need to continually make new measurements and update that. So I was wondering, are you looking at other markets, or is that what you mean when you say you're looking to collaborate, that you want to reach out? Because I understand how to calibrate within the Turk environment. I don't understand how, let's say Facebook said, okay, tomorrow, Michael, let's collaborate. What would the instrumentation be that you would have? Would it be like some kind of ticker where you'd say, in order to log onto Facebook right now, it's going to cost you 5 cents for 5 minutes, and then you would range across that? Is that exactly the direction that you're thinking of with real live websites rather than with Turkers?
Okay. So there's a question of calibration, and there's a question of instrumentation. Yeah?
Yeah.
Okay. So you would want to have as much similarity between these two environments as possible. Right? I think on Facebook, I think what you do is kind of what you're saying. So you would recruit a subpopulation of people, probably using ads if you're Facebook, to do these tests, and you'd start to pay them for different things. And I would only probably pay them to do stuff. I don't think you have to charge them. Okay. You could use non-money incentives too if you want, but that's going to appeal to different demographics of people. Okay. In the process of doing this, you probably want to run the same experiments on Facebook that you run on Mechanical Turk, and then you can find calibration functions across those two. Okay, I've thought about this a little bit, but it's going to be like a bit complicated to get that, but it's probably possible at some level. And now I don't feel like I'm answering your whole question.
Well, I mean, I remember reading the Chi paper, and it seemed like, you used the example of the ads and the irritating ads. And so that showed an example of instrumenting a particular UI and measuring the disutility of introducing the annoyance. And so you can kind of get that. But if somebody sliced up, I don't know, an app, and they said, okay, well, I wonder, should we have a slider here or should we have a checkbox? And then, you would take that little piece of functionality, you'd run it through the Turk, and you would say, okay, we had people repeat this task 1,000 times under one and under the other, and then you would get some induced measure. Have you been trying other things besides this irritating ad as examples of measured utility?
Yeah, I haven't tried any other things yet. But I think what you're describing is something you would do. You could try these small widgets. I could show you another slide, which I've buried in here. Here we go. I'll just ignore the content of this, but except for, this is the idea that maybe you have different scopes of tasks. And so maybe this is all the steps a user might take on Facebook. Or is this the Facebook example? Send an email, Facebook, yeah, okay. So to send an email, you're gonna have to click a bunch of buttons. Okay. You have different scopes of these tasks. And depending on what you're analyzing, you might need a bigger or a bigger scope. So like, you could slice up an interface into clicking a button or try different radio buttons. The problem is that sometimes those might be dependent on other things in the app. A radio button might be really nice in some contexts and not as nice in other contexts. So you have to choose the scope. Basically, every scope goes down as a task on Turk or on Facebook or whatever. I think this is kind of a side point, but it just kind of talks to what you're talking about a little bit.
Well, I could ask 1,000 more questions about this because I'm interested. I just want to see.
So money is a very handy measure. It's fungible. You can apply it to anything. But we all know that particularly online, people do things for many other motivations besides money. Introducing money, in fact, can collapse motivation. It can decrease desired behavior. So when a preschool introduced a charge for picking up your kids late, the amount of late pickups increased because it violated the social contract that it was your responsibility to get there and say, oh, well, I just have to pay, $10 and I'm okay. So there are lots of places where money seems quite unrelated to utility. And I'm wondering if you've thought about what sorts of situations your sort of measurement approach is likely to provide some sort of stable or generalizable measure, and where it's, where is measuring utility with money likely to actually reflect something generalizable and where not? Yeah,
totally good question. Honestly, I should have had more discussion of that in here. So thank you for the question. I think I view a lot of that as fitting to the model human chooser. So we need to have, this is where people are diverting their attention according to money. And if it's a clean experiment, then the user's money will directly reflect how much attention they're giving to different things. What happens in reality is that if somebody offers you a cookie and they're paying you to eat that cookie, that's a signal that there's something wrong with the cookie, right? Which is the same thing that happens with the preschoolers picking them up. If you're picking up people at daycare and you have to pay, or if you pay to pick them up late, then that's a signal that it's okay to do it, right? So on Mechanical Turk, money is just kind of like everywhere. It's kind of like drinking water out of a tap. And you get paid random amounts of money, it doesn't have that much of a signal. And it has some signal, but I think it's a little less of a signal. We should understand in every context how much money has a signal, and you try to eliminate it as a signal as much as possible, and that helps you. So in order to figure that out, you just kind of got to be like smart, right? You got to like look at your situation and be, where is money going to screw up this experiment? Where is it going to be a confound? Where is it going to create dependencies? It depends on all this in the situation you're looking at. But another thing that you can do is you can use things that aren't money. You can use points if you're designing a game. Farmville could give you a cow. There are other ways that you can measure utility. Utility is just your preference, right? I use money because it's convenient and it's global and it's general and it's the best lowest common denominator we have. Does that answer? Okay.
I was about to. Oh, there's one more.
I really enjoyed the talk, and actually I have to be careful because I too could go on for a long time. I think it's a very important problem, and we don't really know the answers, and for years we've been trying. So you referenced my 1983 paper. Well, that was a really long time ago. And you know that not much work has been done on that area. That paper disappeared into a hole. It hardly ever got referenced. It got reprinted once, but I never heard anybody talk about it or anybody follow up on the work. And you know, there's several possible reasons. One, it was a stupid paper, the ideas were no good, or second, it wasn't obvious how one continued. You also noted that it kind of looked like utility. Well, that's not an accident. That the field of psychology, where I got my PhD, was actually microeconomics. So I actually worked in utility theory. Subjective expected utility theory is part of my doctoral studies. That was a fairly big study in those days, and in fact, two other people who worked in the very same field were Danny Kahneman and Amos Tversky. And one of the things that Danny and Amos proved over the years was that utility theory was badly flawed, because the economists have a very simple-minded view of human behavior. In particular, they think that we're monotonic, we're linear. So more is better. So if you have more utility, you prefer it to lesser. But again, Kahneman and Tversky have demonstrated lots of inconsistencies, where you prefer A to B, and you prefer B to C, you prefer C to D, and you prefer D to A, which makes no sense at all, but in fact it's easy to predict and easy to replicate. So what I worry here is, I don't know, I don't have any answer, I don't have any better way. I think you're doing something that's very interesting. I think the money is not the important point. What you want, what the economists want is a single dimension which they can characterize what goes on. And it tends to be money because the economists like it, but it could be anything that's quantifiable, but it's subjected to the very criticism that you mentioned, that it's a multidimensional space, and so people pop out to another dimension and behave according to it. So I was trying to understand how I might work on that. So take a look at this clicking on the big square versus the little one, the Fitts law task. Yeah, it's easier to do the big ones, and if I'm getting paid for it, I'll take the big ones. It's just I can do it mindlessly, essentially. But if I'm playing a game, I don't want the easy one. I want it to be hard. Because I could make tennis much easier, right? Lower the net. So
Yeah.
it's going to be difficult to capture all of those. And finally, these are really small little increments toward the whole. And they don't necessarily add up linearly. You gave the example of uploading photos for my website. The question is, how much do I really enjoy the end result? And you're not going to get at that by measuring how difficult each of the underlying steps are. But I don't want to criticize your work. I want to actually commend it because you're trying. And you're trying to move forward, and I think that's what this field needs. And I think there are problems, and they're well known in utility theory, in the psychology, as you point out, what has now be called behavioral economics. And we don't have the answers, but I think this field desperately needs them.
Wow, thank you for that comment, Don.
Yeah, that wasn't a question.
That's cool. The thing you described about turning Fitzlaw into a game is something I've been working on. Trying to get that curve. It's really interesting when you make something just the right amount of difficult, then it's really fun. Flow? Oh yeah, flow state, yep. Yeah.
The other ones are what we already did. We used to call it HCI in those days, not CHI. In the military, DARPA projects that we did, and also similarly in the humanitarian charity, that kind of work is different, it's not always economics. And in terms of addition to the professor talked about, what you need to do is differential and the double differential cost and the task, right? There are two separate parameters. If you take one with respect to another, when you change one variable and look at what the effect of that variable is a better way to measure relative rather than absolute.
Are you talking about we have two factors and let's look at their interaction?
Yeah, but if you did some change in the design, if you had a design, you change the design, what the result will be. The access will be changed in what you did in the design, user design. What is the result that it will produce, whether it's economic or motivation or whatever it is, the task that's given, that's a better way to measure, it's relative. Utilitarian is a relative utilitarian rather than absolute utilitarian.
Relative utilitarian rather than absolute utilitarian.
You understand what I'm saying?
So you're talking about measuring the difference between two interfaces rather than saying this interface is worth 3 cents.
Exactly. Because they're changing. Like if you go back 2 years ago, 3 years ago, 5 years ago, 10 years from now, the interface will change.
Yes.
You cannot just absolutely put that into money.
Okay.
That's a better way to measure relative for that particular task, rather than compare this versus that versus that versus.
Okay, I appreciate that. I think there's two ways that, and this is interesting. In fact, all the studies I've run so far are comparing two interfaces, and I have not gotten any absolute numbers. But I think but also, even those numbers over time do change. Like you're saying, the absolute will change over time as the Mechanical Turk goes through booms and busts in the economy, right? And people are different.
Look at the tangent, right? As well as the difference in the simple difference, the locus of how it.
Oh, okay. Yes, I understand. Yep, that too.
Yeah.
Yep, that's another thing. Thanks.
So my question, my question actually relates to your Mechanical Turk experiments and the size of the bar, etc. As was commented earlier, clearly the difficulty of the task changed, which can affect the motivation of the person to actually bother with it, right? So have you done any experiments where you actually kept the task the same, but changed the user interface and therefore try to measure what the receptivity of the worker was to actually even attempt the task or complete the task? Because we are actually designing these sort of things, and we're very interested in, does the user motivation to even attempt the task change based on the design? So, and to give you a different example of the collaboration, you change the task by offering to pay me a penny to do the survey. My real question is, how do you measure that without paying me the penny? Because you've changed the task.
Oh, so you're saying that the penny itself changes the task?
Right.
It does, but it only changes the task in the penny.
But it changes my motivation completely, right? I mean, I may just not be interested in filling out the survey. You could pay me $100 and I don't care. So, but coming back to the Mechanical Turk
$100.
Example, let's stick on the Mechanical Turk one
there
just
is
for a
some amount
second.
of money that would get you to do the survey.
Not
if you're a Mechanical
necessarily.
Turk.
Not necessarily. It depends on my motivation to use the product. So come back to Mechanical Task.
Okay.
The difficulty of the task dramatically affected your result, right? The size of the blue box.
Right.
If the task is
But that's
the
not
same,
the task. That's the interface. The task is click the button. The interface itself is changing.
I got to get it in the bar, correct?
Yes.
So it's much harder
It's
to
much
do
harder.
the narrow bar. So the task is different.
Well,
It's not just the
that's not the
user
task,
interface.
though. Not in HCI vocabulary. The task is what you're doing apart from an interface.
So it's exactly my point, right? If the bar you could click in actually stayed the same, but the user interface looked different, then you haven't changed the task. You've actually changed the task by narrowing the bar down. So my question is, if the work stays the same but it looks different, how have you tried to measure that?
Well, the CAPTCHA example measures that. Like the CAPTCHA thing itself is completely the same. The only thing that's different is the distractions around it.
That's measuring distraction. It's not measuring my desire to do the task itself.
Okay, well, I don't think then you could ever actually distinguish desire, this platonic idea of the desire that you're thinking about. I don't think you can distinguish that from all these different variables.
I think it would be interesting for you to try. I mean, I think you've created
Well,
a methodology.
okay.
And there's a supposition that my desire to do the work would change.
We should probably take this offline. Okay.
Hi, this work? Yeah. So you were talking a little bit about game, and I kind of expected you to talk about the reward cycle of kind of like the Farmville effect.
Yeah.
Like for example, in enterprise software, some of our admins they'd rather use the GUI tool, even though it's longer, because of the drag and drop makes them feel like Minority Report versus the command line, which is impressive because then the cost of doing an operation is more, but the reward cycle, I guess, for someone sitting in front of a computer for 8 hours a day is, is higher. So is that something that you guys would consider?
That's super interesting, the reward cycle. I would love to handle something like that. This relates to something that I have a slide on, which I'm thinking about this as ADD. So it's like the amount to which we are more likely to do something that has a short reward cycle than something that has a long reward cycle. Like people send a lot more tweet-sized or tweets than they do full blog posts. And I am trying to run a study that we can find out what this curve looks like. It's some irrational curve or something. So that points to a larger phenomenon, I think. And it's also very relevant just to society. And I imagine if you recruit users from different websites, they'll have different curves, different constants. Like YouTube, people are probably not going to sit down and do a long thing. Does that answer your question?
So another question I had is that you propose them as mystery tasks, and it seems to me, if you were talking about dimensionalizing the space, I could imagine that you could change the framing of what you describe the hit as, and you would get different rates of participation. So it could be exactly the same HIT, right, human instruction task, but under one set it would be, run around after a big fat bar, and another would be earn a penny chasing little skinny bar, or and it would actually, no matter what the description was, show exactly the same interface with exactly the same performance demands, and then you would end up being able to extract out of the presentation how much the description frames the initial motivation.
Oh, that's very good. Yeah, it sounds like a good way to think about that. Thank you. Yeah, you can set the context ahead of time.
Again, I guess the problem that I keep seeing is that when we do talk about this multidimensional space, we've only got 1,000 people in India to answer all these questions, and we're beating them like little schnauzers to answer it all, and we're going to exhaust them before we ever fully define the space.
Wow.
Well, let's thank our speaker. Is there any more? Oh, Steve has a question.
Dr. Norman said that the techniques that you described ultimately are not going to get to the real value of the task. So, for example, we haven't yet measured how much value is represented by the person getting their photos out there and sharing them with their family. Is that the sort of induced measure that you were trying to get with the left side of the curve? And I wonder if you can talk about whether, in fact, that does get to at least an indirect measure of that value?
Yeah, that'd be nice. Thank you. I was thinking about that when Don was saying that too. Yeah. So here we have, yeah, utility is the value of the goal and the cost of the process. And the value of the photos is that value of the goal. And in our Mechanical Turk studies, we're replacing that with money. So we can't actually measure it. Okay, so now we have a real website, and people are already doing it for some intrinsic reward. And now if we pay them, we can see, we call this in economics, we call it the elasticity of the payment, of the curve. It tells you how much money affects them. There are some things that money just isn't going to affect how much they do. But by paying them to do this, we can see how much we pay them. We can see just how price sensitive they are. And
That's why the double difference correct.
oh, really?
U equals d squared v by
D squared v.
yeah, c.
The second derivative of something.
Even derivative doesn't have, but double derivative.
Okay, I'm going to have to talk to you afterwards. I believe, okay, I mean, all I can, yeah, so, what?
The problem I have with this is, and again, it's a problem we all face. The field of human-centered design, which is observations, ideation, rapid prototype, test, compare, improve, etc., is actually hill climbing. And the A/B test that you talked about is actually hill climbing.
Yeah,
And this is a form of hill climbing.
yeah.
And there's a problem with hill climbing. It's a local optimization scheme. It will get you to the top of the hill that you're on. So it will tell you what the optimum is for where you are, but it doesn't say that's really the best result. There may be another hill much taller someplace else, and these methods will never get there. Now, how do we get there? That's the good question. Actually, it turns out I've been writing a paper all day on how we might get there and
You have
what
been.
the problems are. And that's the trouble with a lot of these methods, that especially the ones that we take from economics, where you're looking at a very, very simple structure, adding them up, and then hoping that gets you to the maximum. Well, it does. It gets you to the local maximum, but not necessarily to the global maximum. So suddenly somebody makes a switch from command line interfaces. In the early days, that's what we did at BayCHI. We tried to make the command line interfaces much better, and then suddenly, oops, hey, someone invented graphical user interfaces, which actually are less efficient, et cetera, but easier to learn, and it's a whole new ballgame.
Okay.
And now somebody invented graphical interfaces. It only took 25 years to go from the labs to a product. And oops, it's a whole new ballgame. And so there's our problem.
Okay, I really want to say something about this. So this touches to me on something, which is even, hill climbing is part of this, but another thing that's happening is just that the world is changing from outside of our view. There's something new out there that we're just not even thinking about, right? And, when this stuff comes out of the sides, and I think, this is a huge problem with the whole direction that I'm going here. It's every experiment that we run, you have to think about and manipulate some variable, and you're going to miss out on a ton of variables. And for me, the more I've been doing this and I'm trying to capture the art of HCI, like that was a driving urge for me, or intuition, to do this. How much of this can we actually capture and make a science of? And I'm just like, I don't believe in science that much anymore. I think what you're describing is a problem with science. This is all around. I think it's a problem with psychology. I think it's a problem with behavioral economics, probably. I'm like, an ending PhD student, so I'm going to be kind of pessimistic about some things.
It's interesting that there are huge laboratories all around the world doing fundamental research, and all of these changes that have so changed our lives, none of them came out of the labs.
Right, of HCI.
Actually, in almost any field.
What about Bell Labs?
I really believe that inventions that are radical innovations come from anywhere. They come from someone tinkering in their garage. They come from an engineer who has this wonderful technology and builds something crazy because you can build it. And then someone realizes, hey. So you're right, it's an art form today. And
Yeah.
Well, with that note, I think the speaker indicated he might be able to emit more phonemes for beer. So let's see if we can induce him to do that afterwards. Thanks very much.
Thank you guys so much. I really like this.